So in this lesson, we are going to start talking about fitting functions. Now, this is a big thing that you guys did talk about in Math 1 as well. Um, so you're going to see and hopefully hear a lot of words that should hopefully ring a bell. We're gonna go over all of it, but talking about line of best fit, residuals, scatter plots, all that kind of stuff. And we're gonna kind of spread it over 2 days and then give you guys a day to work. So today we are just gonna review how to do things on the calculator. So creating a scatter plot and then using the residual and how that works to define an actual line of best fit. And then tomorrow, we're actually going to use your homework from tonight. So it's really imperative that you do your homework tonight. It shouldn't take you super long. But you're presented with a bunch of different sets of data that you need to find the line of best fit for. And then those are our examples for tomorrow. So if you don't do the homework tonight, tomorrow you're already going to be behind. So please, please, please carve out some time to make sure that gets done tonight in order to set yourself up for success tomorrow. Because tomorrow we're going to keep that conversation going about line of best fit, but then we're going to take everything we've done so far and use that. So finding x-intercepts, finding maximums and minimums, all that kind of stuff to actually analyze the graph and use that line of best fit that you found. And then on Monday, you won't have any new stuff. Monday's just going to be a classwork day. You'll have a worksheet that you can make sure that you captured everything that you were supposed to from Thursday and Friday going into our review week next week with the test next Friday. So with all that being said, this is the calculator operation sheet that you will get. Notice it says you can use this on the test if it's not written on, so please make sure we try to make it as clear as possible. Part of this is just doing the problem. So the more you do this, the less you're going to need this sheet. But obviously, we're not testing you guys on memorizing a process in your calculator, so we are going to allow it on the test. But please make sure that it's not written on and then it's nice and clean and you're just using it as an aid. So just FYI on that for next Friday. And so I'll keep going through this. I went through and I tried to highlight the buttons that you would actually push. So the bolded words are what the buttons are that you're using in the calculator. And then everything else is kind of an explanation of what those buttons are doing. And then down here, you guys, this, you see new calculator and old calculator. As we go through the examples today, I would like you to please circle the one that your calculator has and then cross off the one that you don't so you don't get confused. But there are two different calculator screens that you will run into depending on what you have. So please make sure that you are kind of following the correct one. So FYI on that. So we'll refer back to this a few times throughout the lesson today. So with that being said, I'm going to talk about the warm-up first. This is just to kind of get us in the frame of mind for line of best fit. And it's two from last year, linear and exponential. So the first one says Gianna invested $80 in the stock market. Her investment over the past few months is shown. So those are just a few data points. If you notice, it says that she invested $80 in the stock market right here. And then we're actually starting at $80. That point is kind of hard to see, but there is a coordinate right here. And then there are data points throughout. Now, we stopped after 9 months. But remember, lines of best fit are all about taking data points and creating a graph with them. So if we were to continue this graph, if we were to kind of connect the dots, it looks as though our graph would look something like that. So it's looking kind of like an exponential graph. And this says, at the current rate, how much money do you think Gianna would have in 10 months? Well, because this is just kind of analyzing and guessing. So based on the line that I drew, I would go to 10 months and say, oh, okay, she probably would have, I don't know, about $650. Now, you guys, this is a total guess, so that's why you see that about sign. And it's kind of determined on how you analyzed the graph. I kind of felt like it was getting a little bit more exponential. Some of you might have kind of lagged a little bit more and had a graph kind of like this. So your answer might look a little lower, whatever. This is just kind of getting the frame of reference. That's okay. This is at the current rate. When do you think Jana will have $600? Well, $600 is a Y value because that's money. So I'm going to go over here and $600. I'm going to use my purple one. I would say about 10 months, but if you had something more like the red, you might say 11 months. So it kind of depends. Again, we're just kind of getting in the frame of reference, so 10 or 11 months, depending on how you went about that drawing. Okay, now for the second one, it says Ken is running a race. His distance to the finish line in miles is shown below. Now think about this. His distance to the finish line. So notice we have distance and time. So as time increases, distance decreases. Because obviously you start, if you're running like a half marathon, you start with 13 miles and you have less to do as time goes on. So that's why you have a graph like this. So again, if you were to kind of connect the data points here as best you could, you might have something like that. So more of a linear type graph. And it says at the current rate, when do you think Ken will finish the race? So according to the blue line that I drew, finishing the race means we have no distance left. So mine hit about there. So maybe about 70 minutes. Oh, that doesn't even come close to what I was trying to do. Let's try that again. So about 70 minutes. Okay. Again, depending on how you drew your line, it might be closer to 65, it might be closer to 75, it just kind of depends. And then it says, at the current rate, how long do you think it will take Ken to be 2 miles from the finish? So again, that's a Y. So we go to a Y value of 2 and analyze that intersection point. So I don't know, maybe 59 minutes for me. Okay, again, that could be different for you. But notice that this is all an approximation or a guess. So I have those about symbols and approximate symbols in front of everything. Okay, so this is what we're going to be doing today. Obviously, though, we're going to use our calculators to make it a little bit more concrete. Okay, so the things that we're going to focus on today are creating a scatter plot and remembering how to do that, and then using the residual to determine the most appropriate line of fit. Because remember, you can get a line of best fit, but it might not actually be the line of best fit based on the residual. So the residual tells us if we did a good job finding our line of best fit. Okay, so that's what's going to go on the blank here. A residual plot. Oh, I'm killing it today, sorry. There we go. A residual plot is used to determine if a line of fit is appropriate or not. So it's kind of like a checkpoint, okay? So you're going to see multiple residual plots. However, we kind of took some pictures, and these are a lot of what you will see, what are the most common ones are. So here, we have 3 different ones. You have this scattered one, so it's kind of going up and down. It's on both sides of the line. And then the last 2 kind of look like parabolas. So if you remember from last year, we do not want the residual to follow a pattern. Okay, so do not want residual. Sorry about my handwriting here, you guys. To follow a pattern, which means I don't like the last 2. So this would be a bad residual, meaning a bad line of best fit, and this would also be a bad residual, also meaning a line of best fit. Sorry guys, I do not know what's going on with my computer. That says bad and bad, but apparently it looks like a 2-year-old wrote it. This is kind of what we're going for here. This is the residual that I like. Okay, it is scattered kind of up and down. We have no specific pattern to it. You have points all over the place. So the less pattern, the better. Okay, so when you check the residual, you want a picture like number 1. If you're getting a picture like 2 or 3, that means you picked a bad line of best fit, and we need to choose a different one. So choosing a different one, obviously we have options. So if you go to the back of your notes, we now have 3 options here for lines of best fit. Last year you only had 2, but now we've done quadratics, and now we have 3. So characteristics of a linear function, remember that is y equals mx plus b. Okay, so we're looking for a constant rate of change. And we are going to look for data points that form a straight line. Ish. Obviously, it won't be perfect with line of best fit, but you're looking maybe for your data to have a constant rate of change or pretty darn close, and for your data points to then form a straight line. Okay, now for exponentials, so we have y equals ab to the x. Okay. So you're looking for your data to increase quickly or decrease quickly. Sorry, you guys, this is unreal. It says quickly. Can't you tell? Let's see. Quickly. So you guys remember exponentials are going to take on a form like this, where they're increasing really quickly, or maybe this, where the data is decreasing really quickly. So that's kind of the shape you want your data to have. Now we added quadratics in, right? So your calculator, we have 3 forms. Your calculator is going to give you ax squared plus bx plus c when we're talking about line of best fit. So what you want to look for is data that can follow a pattern of declining and then increasing. So I'm just going to kind of draw a picture here. So we're looking for data that can go down and come back up. Either in the data set or contextually. Sometimes it doesn't make sense. Or vice versa, we're looking for data that can increase and then decrease. Okay, so I'll kind of talk about that as we look at the data. So those are our 3 options. Those are the different types of lines of best fit that we're going to be trying to accomplish today. So it says, given each situation, determine whether a linear, exponential, or quadratic function would be the most appropriate line to fit the data. Use a residual plot to justify your answer, as some data may appear different than expected. You guys, this is really important. We are going to give you, because lines of best fit, like you guys have been doing that for a while. That was a Math 1 topic. This is really the important part. Is that we're going to be checking, and we're going to give you ones that if you don't check your residual, you could be way off, because especially with some of this data, like depending on what it's presented as, linear can look like exponential because you're only getting a very small snippet of the data. Exponential can look like quadratic, things like that. We want to make sure that you are checking your residual, because that is the key to saying, yep, I'm good. I know I picked the right one of the 3. So in order to accomplish these problems, you guys, these 4 steps are what you should follow, and then your calculator sheet with the instructions obviously does give that to you in more detail. But the first thing we're always going to do is enter the data and then look at the scatter plot, right? Because we have to have an idea of what the data looks like. Now, you guys, there's a lot of times that you could probably look at the data and be able to determine just based on the data which one of the 3 you want to pick. We did that last unit where there was one lesson where you had a couple different charts, and we just analyzed the values in the XY chart in order to determine if it was linear, exponential, or quadratic. Now these values are going to be a little more crazy, but you can also do that. So once we have a scatter plot and a line of best fit, we'll check the residual and then obviously write down the function. So if you look at number 1, it says, Cara is practicing for a marathon. She collected and recorded times and distances so she could predict how long it will take her to run a marathon. So we're looking for a line of best fit here. So we have multiple different distances that she ran and how many minutes it took her to run them. So again, we're going to go through our instructions. So we need to, there we go. We need to put our data in. So you guys, here it says reset your calculator before each problem. So you want to make sure that, especially with these, you're changing a lot. You're changing scatter plots, turning it on and off. It is really important that on these you reset your calculator before each problem, not, oh, okay, I'm going to start doing this and I was in science, so I should probably do this. It's before each problem if you actually want to have the most success and do it the quickest, which I know you guys are really into, obviously. All right, so we are going to reset our memory. We've done this before. So turn on your calculator. You're going to hit second plus 712, and that will clear everything and bring you back to normal. Okay, and then we are going to enter your data in L1 and L2. So you're going to hit stat, and then the first option is edit. And now you should see L1, L2, L3. You guys, side note, sometimes in science you change those names. If that ever happens, if you have L1, L2, L3, you don't need to worry about that. But if that ever happens, you hit second. Sorry, of course now I'm forgetting. Sorry, not second, stat. And go to setup editor. And then hit second 1. So it says L1 and then comma, which is right above the 7. Second L2, comma, second L3, comma, second 4, second 5, and second 6. So basically you're resetting up your lists to be numbered L1 through L6, and then you hit enter and it says done. So if you go back to that, then that would change that back to this screen. So just a little FYI. That rarely happens anymore, but sometimes it still does. So we are going to enter our data. So let's go back to our data. All right, so we have 10, 11, 12.5, 15, 16.8, 19, 21, and 22. I always double check those to make sure that they actual match, because one little decimal, one whatever, screws up all of your data, which I'm sure you guys remember from last year. 112, 115.5, 132, 161, 169, 190, 210, and 219. So a couple things I'm noticing about my data. Obviously, as the distance increases, so does the time, right? Obviously, if the distance is increasing from 10 miles to 22 miles, you're not going to have some sort of change in time that goes from big to small. That wouldn't make sense if you're running farther. So I'm kind of thinking probably linear, maybe exponential. I'm guessing quadratic is kind of out here because it wouldn't make sense for you to run farther but take less time. So if your distance is increasing, your time should be increasing. So I'm guessing quadratic is out, and I'm going to be focusing on linear and exponential just based on the shape of the graph. Okay, so then we are going to hit second stat plot, and this is all in the instruction sheet. I just don't want to keep flipping back and forth. Hit enter. You need to turn that plot on. Okay, normally up till this point I've said turn it off. It's screwing up your graph. But you want to turn it on, and then you're going to hit zoom, this middle button right here, and at the top of your calculator. And option number 9 is zoom standard, or I'm sorry, zoom stat. So that's your data. Okay, so kind of like I just talked about, quadratic is out. I'm looking at that and thinking that looks pretty darn linear to me. So that's what I'm going to go with for my line of best fit. Okay, so in order to find your line of best fit, we're going to hit stat and then go over to calc. Now notice you have a couple options here. You have option number 4, which is linear regression. Option number 5 is quadratic regression. We won't do cubic regression or quartic regression. We will use exponential. So your options here are really going to be 4, 5, or 0. I'm going with option number 4. Now, do not hit option number 4, enter. If you're going to use the buttons, you hit 4, and then once it gets to this screen, you guys, this is usually where most people falter because they hit enter and then they have to start over. Because right now, it's going to calculate a linear regression. However, you also want to look at the graph and see, do you think it's really a line of best fit? So you need to tell your calculator where to graph it. So you're going to go to VARs right here. So down here is kind of kitty corner from stat. Go over to yVARs and go to function and y1. So what you're doing by hitting those buttons is saying, I want this calculator to calculate a linear regression, and I want you to put the equation that you found in y1 so it graphs it, because that's normally where we would enter a graph. Now, if you hit enter, not only is it going to give you your values, it's also at the same time, even though you can't see it, graphing your line of best fit along with your data points. So I'm going to write this down because I don't want to go back and forth. You should too. And this isn't just because I'm doing a video on a smartboard. Whenever I get to the screen, I write it down to make sure that if it is a good line of best fit, I go with it. And if it's not, fine, whatever, I erase it and start over. So notice, you guys remember AX plus B, that's the same thing as MX plus B. So we have 9.05, definitely go with 2 decimal places here. 9.05x plus 19.50. So your line of best fit goes down here. Okay. All right, so we chose y equals, and thanks to my computer being super slow, I already forgot, 9.05 plus, oh, totally not what we needed. Let's try that. 19.50. All right. So you guys remember, this is a line of best fit. So it's not like you can go back in and check all your data points and get exact answers. We're approximating. Okay. And we chose linear here. That's what we kind of were guessing. And it's kind of looking from the data. So now if you hit graph again, this is what I was talking about, why we hit the Y1. That looks like a pretty darn good line of best fit, if I do say so myself. So we need to check it. So this is the important part, is checking the residual, making sure that you actually did do the good job that you hope you did. So you hit second, y equals again, and you're going back into that stat plot. So the only thing you need to change here is you're going to go down to Y list, and you want to change that to residual. So in order to do that, you hit list. Nope, sorry, second stat will get you to list. Sorry guys, I'm killing it on screwing up on the directions. And option number 7 is residual. That's what the resid is. So hit 7 and your screen should look like this. That means they're going to take all of those data points and essentially they plot them as a distance to see how you did. And if you hit, again, zoom 9, that is your residual plot. So I would look at that and say that looks pretty good. Remember, we are trying to avoid patterns. So that looks pretty good. We have a data point up, down, kind of a little farther up, but not quite over the line, back down. There's not really a pattern going on here. So I would say, yes, this is a good line of best fit, which means I can say that I'm good with this answer. So we're good. I usually put a little check mark or something to myself, especially if I'm doing a lot of them, so that I know I checked the line of best fit for on the residual, especially starting tomorrow when we not only find a line of best fit, but now we launch into a bunch of questions about the line of best fit. So you want to make sure you're working with the right one. All right, so now let's calculate the next two. This is the marketing department for a popular video game company tracked the number of game consoles sold per year beginning in 2000 when the system was first introduced. All right, so we have years since 2000 and consoles sold in millions, and it looks like we're going up. Oh, and then coming back down. Okay, so if you notice, we're at 0.2 million, 31 million, 64 million, 81 million, 85 million, 79 million, 73 million, 57 million. Bummer, right? Because that means our data is going up and coming back down, which to me means quadratic is really my only option here. Okay, none of the other two, if you look up here, are going to have values that come up and go back down. So pretty confident that I could find that. Obviously, we're still going to check the residual. So let's run through this again. Again, we're going to hit second plus 712, get rid of all of the data from the last problem. Otherwise, your residuals are still there, your stat plots are still on, and it gets really messy. So we hit stat, edit, and we're going to put in this data. So we have 0, 1, 2, 3, 4, 5, 6, and 7. Arrow over. We have 0.2, 31. Whoa, see? There you go. It's really important to check your math. 31, 64, 81, 85, 79, 73, and 57. All right. So now let's take a look at what that looks like. So I'm going to hit second, y equals, and I am going to turn my scatter plot on so we can see those data points, and then hit zoom standard. And hey, look, it kind of looks like a parabola, just like we kind of thought it would. So that's good. Okay, so now I want a line of best fit. So in order to do that, you're going to go to stat and arrow over to calc. You're not going to use linear regression this time. Okay, you're going to go down to quadratic regression because that's what we're hoping to see, and hit enter. But again, don't hit enter again really quick here. You're going to hit vars, arrow over to y-vars, and then hit function y1. You want to tell it where to graph that line of best fit, and then hit enter. So again, your calculator is, the nice thing is it's not even giving you a, b, and c. It's telling you where to put them. Y equals ax squared plus bx plus c, in case you forgot the standard form that I drilled into your head. All right, so we have, if we arrow down, a function that we believe will work, and that is y equals negative 4.49 x squared. My b value is 39.23, so plus 39.23, whoops, let's try that again, plus 39.23x. My calculator's clearly as awake as I feel, or my computer. Let's see, and negative, so minus 0.025, which we're clearly not going to round because it takes more work to round than to write all three out. Sorry guys, that is really sloppy. Negative 4.49x squared plus 39.23x minus 0.025. That's what that says. So let's check the residual. If we hit graph, we should see the line of best fit go through those points. It's looking pretty good to me. It's not going to be an exact. You can see some of your data points are a little farther off than the last time. However, it is doing a pretty good job of getting around those points. Now the way to check that is to hit second, y equals, go back into that stat plot, or yeah, stat plot, it's right above there, and we want to change y list to residual. So we do that by hitting second stat, option number 7 is residual, and then hit zoom. Number 9 is zoom stat again. It's a pretty darn good residual. You guys, you'll see I didn't take my line of best fit out. That's what you're seeing graph over here, and you might have that too. Don't worry about it. You're just focusing on the residual right now. So that is a good line of best fit. I would be happy with that, and then I would move on to answer the questions that would be posed to me if this were tomorrow. All right, so at this point, you guys, it might be a good idea for you to work through, if you haven't already, work through this last one and see what you get. I am clearly going to work through it and then talk about it in more detail. So, but if you want to pause the video and do it yourself, it might be a good idea, and then check your work. In the mid-1980s, the U.S. Fish and Wildlife Service began reintroducing gray wolves into the regions of western United States where the wolf population had become endangered. So we have years since reintroduction, an approximate number of wolves. Our years are going through a span of 20 years, not necessarily every 2 years, but for the most part. And then the approximate number of wolves, we go from 17 to 21 to 26 to 40 to 50 to 58 to 90 to 139. So we're definitely getting bigger. We're not getting smaller, so I would take quadratic off the table. and focus either on a linear or an exponential type graph. So usually with these, I'm not entirely sure. So I am going to go ahead and put it in my calculator and then make a decision based off my scatter plot. So I'm going to hit second plus 712 again, clear everything out from the last problem about the gaming. Let's go to our, let's go to our stat, edit. Let's put in our data. We have 0, 2, 4, 8, 10, 12, 16, and 20, 17, 21, 26, 40, so just be real careful how you put this in, 50, 58, 90, 139. All right, so hit zoom, and option number 9 is, oh, let's try that again. Option number 9, why do you hate me? Oh, I know why. I got excited. We got to turn our stat plot on. So that's what happens when you make a mistake. All right, so turn your stat plot on. Otherwise, it's not going to graph any of your points. So hit zoom 9 from here. Hey, there we go. All right, so I'm looking at that. Now, that does kind of look like half a parabola, right? A lot of people say like, oh, well, you could just do the other half a parabola over here. But again, context comes in to play, and we're just focusing on year since reintroduction, so from 0 on. So I'm going to go with exponential here and kind of see what my residual looks like. So we have, all right, we're good here. Okay, so we are going to do stat, calc. Option number 0 is exponential regression. So I'm going to hit 0. Again, tell it where to put your line of best fit. So vars, arrow over to y vars, function y1. Go ahead and hit enter. And it's looking like we have an A value of 17.10 and a B value of 1.11. So if we do go with exponential here, that would be y equals, I don't really know why I think I'm going to remember this. Wishful thinking. 17.10. Sorry, guys. This is not good for a good omen for my morning. 17.10, and our B value was, okay, getting over this. Let's try this. There we go. 1.11 to the x. There we go. We'd get there eventually. So we're thinking that this is exponential. Trying to write an E is apparently not a possibility. We're just going to stop there. Exponential, and whatever that is. All right, so let's check it. Let's see how we did. We are going to hit our graph. I always like to look at my line of best fit. Sometimes that tells you, without even having to check the residual, that you were way off based on what your calculator is giving you. Let's check our residual. So we're going to hit second, y equals, go back to our stat plot and change that y list to residual. Sorry, I do this every single time. Second, stat. Option 7 is residual. Hit zoom, zoom stat again. It's a pretty good line of best fit. We got a lot going on there. We're not seeing a pattern, so again, I'm going to come down and say, yep, did a good job. And that is my line. Now, so that's the process that you're going to go through. Real quick, this is that example. So this is the residual that we were just looking at, okay? It matches. I just took a screenshot of it. You guys, if you had chosen linear there and gone with a linear line of best fit, this is the residual you would have gotten. And notice it's following that U shape that from the front of the notes we don't like. So don't love it. Your quadratic residual, not as bad as linear, but do you see how you're starting to kind of get that U shape right here, and then you're kind of coming back down and going back up? Not the end of the world in terms of a quadratic residual, or just a residual in general. However, this is a much better line of best fit because you don't have a U shape happening there at all. So your residual here is definitely the best option for that, which is why we went with it. And then we're going to talk about how context comes into play, and that's going to be some of what you run into in your homework as well. So we'll kind of talk about, we kind of hit on that, like with a marathon one, like it wouldn't make sense for it to be really anything other than linear unless she all of a sudden hit a stride in her training and it turned exponential. But things like that. So it is really important to check the residual. Obviously, some of them will be really obvious, and then some of them might not be too bad. So if you went quadratic on this one, I mean, you could probably make a case to say, well, it's a good residual, but I could make a case and say, yeah, but this is a better residual and we should check them all. So FYI on that. So your homework tonight is to go through worksheet 11, and there are 6 different ones of these, so hopefully it's not taking you too long, you guys. We really just want you to get into the habit of what buttons you need to push and working through the process so that you get quicker at it. And then there are some review problems on that as well, but make sure you definitely come to class with those 6 problems worked out, checked on Google Drive, and ready to go for class. We'll hit the ground running tomorrow.